So I'm going to try to show examples as we go on of different things. The first thing I want to do is talk about the 4 principles of object-oriented programming. I'm having trouble typing. So, object-oriented programming. Okay. What does anybody know what they might be? Might have heard them in another class, particularly if you took Java. There's 4. Inheritance is one. Yes, inheritance, encapsulation, polymorphism. There's one other, which is abstraction. Okay, so those are the 4 principles. And I'm not going to necessarily deal with them in those orders. I think I'll deal with abstraction first. Okay, so what do you think abstraction means? And I will say that if you read long articles or books on these things, they start to read like philosophy. And there are disagreements as to what they mean. But in general.
You extend an abstract class.
Well, so, but why? The trick is, why would you be doing that? I mean, that's actually doing it. But why are you creating an abstract class? Why are you creating? Yeah, you want to generalize. And you want to generalize as much as you can. I mean, and we'll talk about abstracting up. Ultimately, like Java and C#, they abstract all the way up to an object called an object. And every object in the language is a child of object, right? An object just contains whatever is what that part, which is part of every object, which is basically that it has a name and a toString method. And it has a couple of other get type method where it could return its type, etc. So abstraction can, you want to abstract out everything that's common. And we'll look at that. We'll look at a couple of examples of that in just a minute. Encapsulation we talked about. So you want to generalize, and you basically want to group everything that is common, right? So when you make an abstract class, you create a class where all the elements of that class are common to all of its children, right? We'll talk about that. That goes to inheritance, right? Inheritance is anybody?
Child class.
What?
Child class.
It's basically a child, but basically inheritance is the parent is general, right? More general. And the child is more specific. But ideally, every child is an instance of the other. So we're going to do something like, if you did, you have a lot of different roles for people, but they all have a name, they all have an email, they all have these same fields. So you could put all of those fields in like a person class. We'll do this in just a moment. We'll diagram it and I'll show how that would look. And then you might have a customer class that is a child of person. And you might have an employee class that is a child of person, right? So a customer is a type of person. Employee is a type of person. They call it an is-a relationship. And the thing is that you don't have to repeat in every class all those common things. They've all been filtered out by the classes above it. Does that make sense? And when you inherit, that means that the child, which is more, again, more specific than the parent, inherits, gets every public field and method that the parent had. It doesn't get the private ones, only the public fields and methods. And inheritance is really good for code reuse. So there is some arguments, as I said, they can get philosophical, that inheritance violates encapsulation. Anybody have an idea what encapsulation?
Separation of concerns.
Yeah, basically it's the idea, actually that's a good way to put it. Separation. And more than that, every class should be its own self-contained. And it should have as few, ideally zero dependencies, but as few dependencies as possible, right? So every class should have all the stuff that it needs to do what it's going to do. You should never have to, if you change something in another class, it should never require that you change something in this class, right? Every class should be as independent of the others as possible and as self-contained as possible. They should depend on other classes as little as possible. This is why some people argue that inheritance violates encapsulation, because they do depend on a parent class. And there are people who, inheritance is really common. There are people that argue that it should be less common in programming. We're not going to worry too much about the philosophical arguments in it, but just, does that make sense? Encapsulation is the idea that it's part of the component idea. I mean, in an ideal world, you write a class. It's a perfect class for, say, point of sale. Every time you have a point of sale, you just plug it in and it goes, right? You don't have to worry about, it's just like a circuit board. If you improve your point of sale, you just unplug the old one and plug the new one in. Right? That's the ideal. It doesn't happen very often, but that's the ideal. Does that make sense for encapsulation? Let's look at polymorphism. It's a nice Greek word, but it means many shapes. Part of polymorphism is that it should adapt and behave differently depending on the environment. So the class, it should have some flexibility in terms of how it works. And in practice, what this means, and we'll look at this in code, because I don't think it makes sense to you unless you see it in code, but it basically means overloading methods and overriding methods. It can also, in the newer elements of language, it's also part of generics. Does any of that mean anything to anybody? What is overloading a method? You guys know? I'll show you in a bit.
Just giving it more parameters or something, you can change the signatures.
So you change the method name stays the same, but the parameter list changes, right? So basically, you can have, say you want to do something that says square root. Typed languages like C# or C++ or Java, if you say that the data type is an int, it won't give you a square root of a decimal, right? Or a numeric, or double. So you also have to do a version of the method with a double, right? If you want to do it with a decimal, you have to do a version. So each of them has a different signature. They take in different kinds of parameters, but they all have the same name. Now, before generics, that was how they always, if you wanted to do something that handled any data type you threw at it, That's what you had to do, is you had to overload it. Give 15 different versions of the function, but with different data types. With generics, you can adapt the data type. The data type is determined at runtime, so you only have to write the method once. Overriding is from inheritance. If a parent has a method, the child can have the same method, the same name, same signature, but it can have a different content. They can overwrite it. They can change how that method behaves in the child. And we'll look at that in a moment. So those are the four principles: polymorphism, abstraction, encapsulation, and inheritance. Does that make any sense at all? They're fairly, speaking of abstraction, they're fairly abstract. But they have some concrete effects when you're actually building things. Yeah.
Explain generics a little more. I'm a little.
So
what goes on there.
generics, you've done like lists in Java. So a list is a generic. You know, it has the angle brackets and you put in the type.
Right.
So what the thing is that it's written in such a way, and they had to modify the language to allow this, that it doesn't have, you write a class or you write a method, and it doesn't take a particular data type. It takes a placeholder. And when you initialize that object, you have to tell it what kind of data type it's going to be. So you initialize it as a double, or you initialize it as an int, or you initialize it as a string, or you initialize it as whatever kind of object. And so you, instead of having to write 15 versions of it, you just write that one version with basically the type placeholder. Yeah, generics are neat. I don't know of any class we have. We use a couple of generic objects like list, but I don't know that we've ever actually gotten into the principles of writing with generics. They're kind of an advanced topic, but all right. So let's do a diagram kind of related to something that you were working on. And then I'll look at it in code a little bit and we'll see. Set 2, why am I not getting, oh, I just need to do a plus. So let's think about the person people thing. We'll look at kind of the inheritance of things. So I'm going to do a class. And let's say that we had a class called customer. And let's just put some fields in there. I may not do as many as you might have, but let's say that they had a customer number. I'm not going to do data types for now. And it probably should be, and let's just say name, email, phone. What else would we want in there? I don't know. Do we want their address and all of that? Let's just do phone. And then I'm going to add, one of the things a customer can do is, so add, let's say they can add coupons or something if it's a store, right? Anything else we want the customer to be able to do? What? Yeah, although actually, so this is an area that's a little, generally you don't want, because of encapsulation, you don't want a class to be able to change itself. Does that make sense? You'd have another class that would change it. In my card game, I had a shuffle method inside the deck, and I realized it probably shouldn't be there. It should be in the game. You shuffle the deck in the game. You don't shuffle the deck in the deck. So, but yeah, generally you don't want to do, like a customer, I used to do this, but you don't want to do things. I would do like add customer, right? But you don't want to add a customer in customer. You want something else that adds customers. Does that make sense?
For that,
What?
for that lookup.
Well, I'm just going to do, I want to show a specific thing, sort of. So let's do employee. I'm actually going to do salary employee. I'm going to do a couple of different kinds of employees. So they would probably have like an employee number. And they would have a name and an email. Yeah, so we might add things like position, maybe a hire date. I don't know if you need that in the class, but let's do that. So, and actually, so let's do salary, if this is a salaried employee. And then we would do, I don't know if you'd want to, I don't know that this would belong here, but we could do like calculate pay. Maybe calculate weekly, monthly. Let's do monthly. All right, so let's do another employee. And this one will be, let's just call hourly employee. Okay, so they probably have a lot of the same things. You know, so I'm just going to go through here. You can sort of see where I'm going. We're making a lot of repetition. Position, what? And I'm going to do a hire date. Same thing as the other, but this, instead of a salary, they'll have an hourly rate. So, and then we can do calculate monthly pay. What? I didn't hear. I'm just going to put their hourly rate. We could do calculate. Now, one of the problems, so this would probably take in, calculate, should probably be spelled something like calculate. Guess I just left out an A. This one would probably have a little bit different. It would be like an overloaded one.
You're using an H.
From what?
The month.
Oh, monthly. Thank you. It probably should be public. I don't know, would you put hours in here? I mean, you'll need them, but. And I'm assuming sets and gets for all of these. All right, so we got customer, we got hourly employee, salary employee. What?
You bring the hourly employee up.
Oh, sure. I'm just wondering if I should have like a people that are paid by contract or something as well. I don't know if we need that many. We're starting to get into Amazon level here, I think. Although actually, here they have. Ugh. And I want a line, a separator, actually. That's what I really wanted. So they wouldn't have a salary. They would have, I don't know what you want to call it, contract rate? What? Yeah. And we'll do calculate monthly also. So the obvious problem with these, you guys have one of the things, this is true as much in classes as it is in databases, you don't want to repeat things. Right? These all have essentially the same things. Now, customer is a little bit different. It doesn't have like the hire date and the money stuff or the position. But it does have, the customer number and the employee number. Are they similar in numbers? I mean, you could just do number, right? So one of the things, let's see if I can do it all on the same screen, maybe. Abstraction would suggest that we put out all the stuff that is common. It doesn't have to be named person, but whatever you want. And I'm going to take most of the stuff from customer because customer stuff is everywhere. Yeah, that didn't work. Actually,
Enter.
I think I can get it. I just need to.
When you need more space, you click enter and add enter.
What?
If you need more space, you click inside and click enter and get more space. Okay.
Yeah, well, it's this one, this last thing that I need, but I think I can bring it up. There we go. So I'm going to delete. I don't need that anyway. So this is our person class. It basically just has all the stuff that's common to all the people. A customer has add coupons, and I'm going to change this from customer number to just number because it could be employee number or that. So is there anything about it with customer other than coupons? There might have been stuff we didn't add.
About history.
Well, I mean, we could do. All right, so you could inherit from person, customer can inherit from person. That means that they automatically get number, name, email, and phone. And the only thing really unique about them is that they could add coupons. I mean, there would probably be more. I didn't go into all the depth. So when we look at employees, one of the things is that these are all employees, right? So I'm going to create a class just called employee. And everything that's common to all of the employees, which would be the number. Well, actually, we don't need number. We don't need email. We don't need phone because we're going to get those from the person. We just need position, hire date. So I'm going to just do a minus for position. And I know I'm being inconsistent. Not that it matters a ton, but, and then I'll do calculate pay. And this one would also inherit from. So this is doing like two things, abstraction and inheritance. So these are the things that belong to all employees, right? The other thing that I would probably do, and I'm not entirely sure how to do it in this diagram, but I would probably make this abstract. Do you guys know what an abstract class is? Anybody have an idea of what an abstract class is?
Something that does not fully implement the methods.
Right, and you can't implement, you can't make an instance of them, right? They're only there for parent. You can't actually in your program create a employee equals new employee. Because it's abstract, because it's only being used for the inheritance tree. So then underneath this, what we could do the hourly, the contract, and the salary employee, and we would get rid of everything that doesn't. So we don't need number because we're getting that from the parent. Don't need name, don't need email, don't need phone, don't need position or hire date. And we're actually getting calculate monthly pay, although we could override that. And same here. The only thing that we need to keep is contract amount. And this is hourly rate. Again, we don't have to do that because these will all get it if we do the inheritance now. And what I'm going to do is I'm going to code these real quickly, not with any depth, but just so you can kind of see how that works. Questions on this? Does that make sense? I mean, what we're doing is just trying to eliminate duplication.
Did you say earlier that child classes only inherent in public?
They do. So I'm assuming that we've got a public given set on those fields. So, and I will do that when I code it. But yes, you're right. If I left them as is, I mean, if I didn't give them a public version of that, actually I'm not inheriting from customer. There. Let me just move this over a little bit. Does that make sense sort of as a tree? So we got the abstract person, we got an employee and a customer, and then we've got the different kinds of employees inheriting from it. So as I said, this is two principles. It's abstraction and it's also inheritance. Also, calculate pay. We're going to use overloading or overwriting for that because each of these will do calculate pay differently than the parent, right? So that's polymorphism. So it's got most of the stuff we're interested in. Questions on? Is it making sense? Once we get the relations down, I mean, once we get the principles down, we'll talk a little bit more about some of the other relations. Do you guys want to see a little bit of this? I may not do it all, but some of it in code.
Sure.
Okay. So I have Eclipse up. Java is a good object-oriented language. There's also Visual Studio on here. I could do C#. Let me. I want to change the fonts. See if I can remember where that is. Is it Window Preferences? General? Editors? I'm looking just for fonts.
I think it's the drop down editors. There's a drop down editor. The arrow. Look.
Under Editor?
Yeah, under editor. You can click and you can drop down.
Where?
Or just the window you open, you can see them. Because he has, I don't have them. And he forgot to out.
I didn't want to do that. Now I may be screwed. Edit. So I want the window back. What? The arrow. Right. Window. Oh, preferences. Okay, so I just want to make it big so you guys can see it. I thought editors.
Yeah.
But I don't see, so text editors, I just don't see the font. I can zoom. Maybe I'll do that. It's been a while. I haven't taught Java in a long time, though I was playing with it a little bit. Parents. No. It's got to be easier than this. Appearance, font. But that's just the theme is Windows. What?
Maybe you can put from search
Search.
on the left side.
Oh well. Let's structure text editors, task tags. Enable animations, show color and theme, and font theme. That just gives me palettes. All right, I'm not going to look forever, but I also need to close this. I don't want outline either. I want, is this the code window? That's not what I wanted to do. Okay, let's reopen and see if it goes back to its defaults.
Color font here.
Where?
Go to Windows preference.
Yeah, I was there.
And then go open it. Preference. And go to the general and appearance.
Yeah, I did.
Yeah,
I thought I did that.
The drop down, there's a drop down. The arrow, the bracket. Yes.
Oh, there's colors and fonts.
Okay, color and fonts. And then you go
So then you have to find the Java, the code.
See down here is,
Still not worth it.
I remember what's called text fund.
Descriptions, Java doc, declaration. Where are my code window? Is that the code window? Shouldn't be open perspective. Java.
You have to click and edit it. Text fund, okay, I go edit.
That's not doing it.
Yeah,
What?
you have to edit it.
Well, I was going to magnify it, but I don't have my Java window open.
Do you
The
wanna,
text editor, the code editor.
you wanna take a look here?
Well, I'm not going to worry about it.
Right. You go Java and Java editor text fund and click edit. Also, you put preference. What you looking? Preference. The last
Yeah, I
one.
know. I'm looking for. I don't have my new Java project. I'm just going to name it. Let me zoom. I'm just going to zoom.
See? Wow.
All right. So I'm just going to name this inheritance examples or something. And I don't think I need anything there. I'm just going to finish.
So only my machine has no escape, right?
I'm going to do a new package. Source.
Just right click new.
Yeah, and then I can just do package, yeah. I'm just going to do com.spconquer. I had no trouble with this when I was doing it at home. And then I just want to add a new class. And the class I will say is a person. We'll do the abstract class first. We can click here if we want it to be abstract, or I could add it later. There it goes. Boy, even at 200% zoom, this is tiny. I think I do need to.
I can help you make the file bigger.
All right, so preferences.
Yes. At the same place, then the Java editor, the middle one in the window. Okay.
Java editor.
Yeah. I click edit.
Oh, edit. And then
And go whatever size you want. 36.
let's do 28 and see how big that is.
Apply.
Okay, and then let me unzoom and see if that makes it. Is that big enough? All right, so we've got a public abstract class person. So I'm going to do what we had, like string name, right? And string in Java is capitalized. So what else did we have? I could go back. Private string name, private string email, or
Number phone.
yeah. So let's do number, and I'm going to actually make that. I'm going to leave it. I'm going to leave it a string. Name. Okay, so this will be our fields. In Java, you can do Let's see if I can get it to do what I want to do. I want to refractor. Have they changed the refractor? There it is. And I want to, actually, I don't think I even have to do that. Isn't there, if I just do over this, it create a getter and setter. In that yellow menu, there's a create getter and setter. Because you don't want to write these if you don't have to. All right, so it did a public get and set for each of those. And that would be my abstract class person. Does that make sense? Questions on that, other than my fumbling with Eclipse? I used to be really good at Eclipse because I was teaching Java a lot, but Stanley teaches most all the Java classes now. So basically, this just exposes the fields, right? And this is an abstract class, so we can't make it new. But let's add another class. So I'm going to add a class. And I don't know that we'll do all of them, but let's do customer. So I'm going to add class, and I'll name it customer. You almost need to zoom for the dialog boxes. Now I am going to say extends person. And in Java, that causes it to inherit from person. So it should have all of the fields that were in person. And in customer, the only thing we really had was a method, right? Which was public. So you know what, actually probably we would need to, we don't have this, but I'm going to well, let's don't worry about it. Probably we would need an object for coupon. So right now I'm just going to add a string, but you probably would want a list, and again, string is capitalized. And I need to give it a variable name. Okay. And it'll be happy with that, even though it's an empty method. Yeah.
Pointer is void, and chaos is also was void.
So void means it doesn't return a value. So probably what I would really want here is like a list. And we didn't put this in the thing, so I'm going to do, actually, and here it's an array list. I don't know if it'll allow a string in an array list, will it? And what it's complaining about is I need to add that. So import. And then in here, I would do coupons add coupon. And it would create a list of coupons. So that's how it would actually work if we were doing that. And this is a generic, right? It's given its data type at runtime. Yeah, whatever a coupon is. Now add, I think add is lowercase. Okay, so that's one. I'm going to actually add one more class, just so you can see something about the customer. So I am going to add a class, a new class. This one will be the main. So I'm going to, I tend to call these program. And I'm going to put a public static void main in there. And part of what I want to do is I'm going to do customer. And when I do customer dot, so let's do customer C equals new customer. Is it seen customer? Should. So maybe I want to zoom to show you the IntelliSense there. So customer, when we do that, it has add coupon, has the array list for coupons. It has get email, get name, get number, get phone, hash code, and some of these others are from just being an object. But it has set email, you know, as you go down. It has all the gets and sets from the abstract class. So if I wanted to set the customer's name, I could do C dot set name, and then in here where it says name, I can just do, I don't know, George, and close the quotes. Right. Even though we didn't put these into the, there they have them. I'll do just a couple more, not a lot, because I don't want to belabor the point too far. But are there questions? You kind of see how the inheritance works. So let's go, and we could, if we wanted to, there's some things we could do in, I'm going to go one more thing to customer Java. I will add one other method in here. And I'm going to do public string to string. And I'm going to return so you guys know the toString method is in every object. You can use it to return. This is overwriting, so this is polymorphism, right? We're overwriting an existing method. And so in the program Java, if I really wanted to run something, I could say, oh, what is the object in Java for writing to the console?
Oh,
Scanner. And again, I have to import it. Is it just print line, or is it scanner dot? There is a system dot out, right? You can do maybe instead of scanner, because that takes some. What? Well, that takes a line in, right? I think I want system dot out dot print line, and then just do C dot toString. And it will print, if I run the program now, it'll print George. It'll be very exciting, I think. Down at the bottom, I don't know if you can see that. Tiny, tiny prints out George. All right. So that's an example of inheritance there. And polymorphism to a little bit, and a little bit about abstraction. I could do customer and I could break those up, but I don't think it's worth doing unless you really want to see it. Yes, no, maybe. I guess let me tiny bit do employee and then one of the employees, just to show you that it steps all the way down. And then I'll do it really fast. I won't add a lot of detail to them. So let's do employee. So I'm going to do new class, employee. I will make it abstract as well. There are other principles here that get really subtle. You can always substitute a child for the parent in inheritance. So what that means in practice is that if you don't know, for instance, what employee you're going to be using until runtime, you can actually pass it employee and then substitute contract employee or something for the, you can substitute a child for the parent. Substitute contract employee for employee or hourly employee for employee. I mean, you can use it as a signature in a method and then pass a child. That's how they do, before they did generics, one of the ways they would do things is that they would have the type of argument that it takes to object, because everything is a child of object. So it means you could pass pretty much anything in. Oh well, we'll worry about that later. So what did employee had? It had some fields, right? It had private. What? What were the, yeah, so it had, well, not name, because we did those in the, oh, the other thing I need to do with employee is it needs to extend person. All right. And I just need to see my diagram because I don't remember what employees have in it. Just position and hire date and calculate pay. So I'm going to go back. And I really want my strings to be lowercase today. What is the Java date time? Oh well, let's just do it as a string. Does anybody know what the Java date time is? There is one. I've used it. I just don't remember. Local date time? Daytime. Anyway, I'm going to do a create a getter and setter. And I'll create a getter and setter here. And then I will create a one more method, which will be basically we wanted to calculate date. So I'm going to do public. Did I do it as, I didn't give it a type. Let's do it as a double. I probably should take some arguments. because this is an abstract class, I shouldn't have to. Oh, it doesn't want me to. It wants me to add somebody. So the parent class isn't very useful for the method, but it's basically because every child will have to override it. Okay, so that's the employee class. Yeah.
With the calculate page, the child classes instead of parent.
So we'll put it in the calculate. You could, but since they're getting it, I mean, they all have it by default now. So the other way to do it would be to create an interface and force them to do it. Does that make sense? Yeah. We'll do interfaces later. All right, one last class, which will be, let's do salary because that's easier. So I'm going to do new class. Oops, yeah, did I do it from the right place? Yeah. Salary employee. And the salary employee extends employee. And maybe when we're done with this, we'll take a break. And then I'll talk about the relationships between classes a little bit more. So let me look at my diagram. I don't think there was much in here, right? Salary employee just has salary. So I'm just going to do private double salary, and I will get the getter and setter for that. And I'm going to override. Now I think I can just override it. Can I? Public double calculate. What I'm not sure is if I had to write overridable in the parent. Does anybody know?
I think the calculate rate is from the, not the capital letter, in the other one.
What the other class had a.
Employee
Oh yeah. So let's go back.
on the bottom.
It needs a return type, but I also want it to. Doesn't seem to be requiring, so I'm going to return I'm going to assume that the salary is a year-long salary. So it's happy with that without actually having me write the word at override there. Does it have? No. A lot of times it wants. Let's see what happens when we run it. So I'm just going to add a salary employee SE equals new salary employee. If I do SE dot, notice again I can get all the stuff from person, all the stuff from employee, so it steps on down. And then I'm going to do, so we'll do set the name. So I'll do set name. And we'll say, I don't know, for whatever reason, Jenny. Okay. And then we'll set the salary. So I'm going to set salary. What do we want to pay Jenny for a year? $30. Poor girl. Yes. All right. I'm sure you don't want 30,000. All right. So there, she's not going to get much money. I'm going to do. Let's do. I'm going to do a system out print line, I guess. Let's just print line, and then I'm going to do so se dot get name plus comma plus se dot get salary plus comma, and then I'm just going to do for the annual plus se dot calculate pay. Let me break the line since I'm still zoomed so big here. And I think, do you do, is it 2-string now, or do you need to do string? That isn't how you do it in Java, I don't think. I think you do what is that? Just that. See if it'll do it without conversion. So let's run it. So she gets $2.50 a month. I don't think that job's worth it. If she were to get 30,000,
Unless you add K in the end,
you could add K at the end.
it would make sense to have K in the end.
I don't know if I want that space there, but I did it 30,000 this time, which is still not a good salary, by the way. 25. It wouldn't be 20. It's just 2,500, not 2,500K.
Yeah, to the previous version, if you add K,
Oh.
it's at 30K.
Yeah.
It makes sense. It'd be the same as right now without it.
Yeah. Oh, if I'd done 30K.
Correct.
Right, but it wouldn't have treated that as a math thing. All right, so it works anyway. So inheritance can save you actually a lot of work. And then the thing is, when you have something like this, let's go back to the diagram. You can add as many different kinds of, you can plug in new kinds of employees as many as you need, right? Because they all can inherit from employee, so each of them is a type of employee, and you can add as many as your company needs. Why don't we take a break? My brain is gone. And then we'll talk a little bit more about the specific kinds of relationships, because we've talked about one. We've talked about inheritance. There's 3 other kinds of relationships. Is this making sense, helping at all, or just...
I mean, I've done it for other things.
I know, but.
But I don't know if
You're just saying, you don't know what it's like.
However, I do know how much money you get in this data for training. Like 1,300 a quarter. Not before. It's about 2,000.
Sure.
I missed how you put in the connections among the different.
So I used inheritance. So there's one of the relations says
Oh,
inheritance.
okay.
And the arrow always points towards the parent.
All right.
So they come down, it comes in like the musings backwards, but the arrow always points towards the parent.
All right. Thanks.
So yeah, I mean,
Oh,
these all point to the parent and then these point to that parent.
okay.
Have you been in the services? Blood job services in the last 4 years? But there are categories. Do you remember that email I sent?
Yeah. I know, I just don't need to read it. I just.
Oh, 'cause it's-
Yeah.
Thanks.
Okay.
I'm just gonna tell you in one word.
It's good because I mean, I'm not.
So just apply for that through return.
Yeah.
So here's how you do it. Find a code that you say that that's what you do. Yeah. And then you just keep saying it. And you make it so that it's. No, but you, so, okay, so here's a code I found that was good for stuff. And you have them, yeah. So.
So brain walking.
I don't know, it's, I
I
was a little tired to start the day,
can
so.
tell you're so tired. Taking many different
I'm
classes.
not telling you,
I am.
I'm not.
I'm not saying that.
I'm not telling you
Can I,
to tell the truth.
can I ask you a question?
I'm just giving you information.
Am I going to ask you a question in the break?
Yeah, of course.
When I'm working another project for ITC 285 and get the important FIC, draw the disability diagram, my queries, and then the databases, that was procedure. Yeah, but I'm not sure the diagram is correct. I have to. What's the forward?
With every quarter, you have to
have an idea what it is.
Warranty is how the tables relate to each other.
So I have some comma, only 3 tables,
Okay.
And every
three
quarter.
tables, and then when they,
So need volunteer area here would be the foreign key.
there's a point. This one is one. How do I get a point here? Where?
So just right click on it
I click on it.
and then set one.
Okay. What else? So have a tie. When they click, they can check what area volunteer they can check as well. So it's supposed to go like that.
Well, so that one, oh, so the volunteer, need volunteer
Yeah.
area.
Uh-huh.
It should be, so need volunteer area,
I actually don't think they should have the same keys. Keys are actually best done as like just numbers.
I thought they have the common together so that click to select the other table.
Right, but usually they're just numbers to relate them.
So key.
Yeah, so they should be keyed in foreign key.
All of the three table area key.
Every table should have a key, and then when they relate to each other, you repeat that to make a foreign key.
Sorry.
So you have a key, so let's say
Yes.
customer is the table,
Yes.
and you have a customer key.
A customer key.
And typically that's just a random number. Maybe you got your name.
Yes. When the customer key goes to the other table, becomes foreign key.
Yes. So if you do a sale here, you have a sale key. So these are the primary keys. And then customer keys, that's when it's making the first sale.
Yes. So
Would
become
be a foreign.
Because the comma, okay, got it. Yes, makes sense. What about more element connected with the like dated time?
Yeah, well, so this one has the date. This one will have the time. But generally, you don't want to repeat things across. So
When he has, the sales has it, the
the
customer doesn't
customer is
have it.
tied, it doesn't have it, it's tied to it by the customer key. The customer is tied to this sale.
Oh, so it appear anyway, right?
Yes.
When he has it, and the other people also
It
has
tells
it.
them how they relate. So this sale belongs to this customer.
So, as long one table got a day and time, the other table.
Right, in fact, you don't want to repeat them.
Yeah. I was afraid if I click the other table, they don't have it, I don't get a seat.
Yeah, but you have to do it through joins. Remember doing joins?
I guess I come to examples. I just forget how the, thank you.
You have to go on the.
So is that a procedure because every, in the class, we follow each other step by step. I'm organizing my step what I done. So like, first the diagram, your steps, and write a query. And you say, in the morning, you say, when I connected the database, it's not related to the end. I think they are related to the end, because I created the database in order to store the data.
But some of the data that we stored, like a new person, is not in the database.
Oh.
We're storing the data that comes from the form.
Oh, yeah, from the form, where to get it back?
Well, so once we take it from the form, we pass it through the store procedure to the database.
To the database.
So the
You store it,
Yeah, it's stored in the database,
but not restore it.
yeah, but the class itself isn't directly related to the database.
Okay, not pre-store like a book.
Right, like book and
Something that
they already have
sale.
they have data in them, so
Yeah.
they're
Where the sale
directly hooked to the database.
Display first.
I didn't say how long break is, so it'll probably be forever. That's okay.
I guess I cannot remember. I haven't, I mean, I have plenty of people on YouTube, how much you can see
Still quite a few people out.
What
I
about?
bet. So we'll get going in just a couple minutes. I'm gonna get them. And I think what I'm gonna do is I'm gonna talk about the 4 types of relationships, and then I may let that be good for the day. Yeah, take us to about 3 o'clock. And then there's a few other little bits, but it'll give you enough that you can start if you want it next time.
We've actually been talking about like getting rid of this stuff.
So let me just see how many more people. Yeah, I'm going to need another Bible. So So I know this is a lot of talk and it's fairly abstract. The code was supposed to make it less abstract, but it may not, particularly if you've never coded. When you're drawing things, there are basically in the diagrams, there's 4 different types of relationships. One of them we've done quite extensively, which is inheritance. That looks wrong. It looks, I guess it's right. So let me look, when we look at the diagram, all of these are inheritance relationships. And they have the clear triangle, right? That's inheritance, and it always points towards the parent. Right, so inheritance, the arrow always points towards the parent. So the parent of contract employee is abstract, is employee, hourly employee, etc. So these all have, and then customer and employee inherit from person. So that's inheritance. That's what it looks like. It's a clear arrow. The arrow always points towards the, or clear diamond or triangle. It always points towards the parent. Is inheritance kind of makes sense overall? We did a bit on that. All right, so another one is just association. Anybody have any idea what association is? It's the simplest kind of thing.
Like when you have an enumerator.
Well, it's just, actually they do use association for an enumerator. But it's kind of like, we didn't do this, but so I'm going to just call this class program. I'm not going to fill in its details, but this would be like the one with the main. And we called the salary employee. So association is just a line.
Connection.
It's, yeah, basically it's just a simple line connection. Right? All it means is that one program talks to another, calls some method in another. Right? So if one program just calls one of the methods in a class or gets one of the properties from the class, that's an association. Association just means that the classes talk to each other. That's all it means, right? And that's fairly common. A lot of times all you're doing is you're just calling a class to get a single method or something. Does that make sense? So when you're diagramming inheritance, inheritance may not happen if you're looking at it. I mean, the inheritance is, if you have a lot of things that are common, you move the common things up to a parent class, which can or doesn't have to be abstract, but can be. But if you don't have a structure where you have a lot of repetition, you may not have any inheritance. Does that make sense? Not all of these happen all the time. Association is almost always there because it's just classes talking to each other. Another type of relationship is composition. Anybody have an idea what composition is? I'll do a drawing of that in a second. How would you normally think of the word composition? Oh, well, that's a good.
You have like a event controller and like a main class.
Well, one of the things, there's probably some relation. It essentially means one class is contained in another. Does that make sense? So I'm going to do, this is related to the deck class. I'm going to create a class called card. And a card has a suit without the E. And it has a number, right? Or let's call it a value. It has basically a value. It also has a name, right? So that's a card. In mine, I also had a toString method, which is fairly in-depth, where it gives it a name. So like if the value is 12, it's a queen. If it's 13, it's a king, so it substitutes the numbers for the name. So I'm going to do a deck. And what is a deck? It's an array list of cards, right? And it might have some methods in it. My one has a populate. That would be, and actually that is I did make it a private method. So the thing is that a deck consists of cards, right? And so it's not just a normal inheritance relationship. The card class is actually contained inside the deck. And the relationship for that is composition. There's also aggregation, and you could argue which one it's going to be. I'm going to do this as composition, but there are arguments. I don't like the way that's hooking. Let's hook it over.
Can you give the explanation when you start to take the connector?
The connector is composition.
Well, that's what I'm saying. Can you put explanation?
Sidebar?
Yeah, I'll put it in maybe in the notepad. I guess I could put it here too.
Okay.
So composition means that the object is contained in another object. It also means that if you destroy the deck, say you took the deck and threw it away, you would also throw away all the cards, right? So the things don't exist separate from the container. It is arguable. I mean, you could have arguments about whether the card exists separate from the container. But within the product here, so is the deck, let me get a text box. So composition. The object is contained in another object and would be destroyed if the containing object is destroyed. I don't do this anymore because memory management is better unless you're writing in C++, but with every class you had to write a destructor as well as a constructor. You had to tell what to do to get rid of it in C++. So destroying a class means to remove it from memory, basically, and to shut down all of its variables and things, to turn them all to null and remove the class from memory. So, does that make sense? Composition is where, and there's a lot of instances where this could happen, right? Classes that contain other classes. And this is one. As I said, you could argue. The other way you could do this is, let's do a slightly different one, and this will be the fourth one. I'll put it down here. The fourth one is aggregation. And aggregation is just like composition, except that, okay, let me go back. Aggregation. So these are the four relationships: inheritance, association, composition, and aggregation. I'm going to post it too. You're welcome to post it. So if I go to here, I'm going to do, I'm actually going to call this, so let's call it a class section. And by this, what I'm talking about is like in a school, like this is a section of the class. And I'm going to make another class called student. So a section, among other things, would consist of an array list of students, right? And I'm not going to put all the field names in the student. I'm still in text mode. Okay. The difference between aggregation. Oh, I hate that. Let's see if I can move this. Aggregation and composition is that if the class is destroyed, the student survives, right? The student has an existence outside of the class, whereas the card we're saying doesn't have an existence outside of the deck. Again, that's arguable, but we're going to say that. The only difference between these, this is a clear diamond and this is a filled-in diamond. The only difference, and I'm never going to be strict about this for you guys, but the only difference is that this means it's wholly contained, and this means that it contains it. The class is composed of it, but the other class, the student class in this case, has an existence outside, separate from the containing class. Does that make sense?
Wouldn't it be that, like a object would have a pointer to an array, so the array would have a different memory location, whereas
It could if you were doing it in C or C++.
but in Java it would be the same memory location.
Well, so no, actually it's underneath Java, you're doing pointers and stuff too. It's just that Java does it all for you, right? You're not allowed to actually do an explicit pointer in Java. But it still is true. Whenever you have an object, we're not going to worry about that right now, but memory management, the compiler, the way the programs work is that you always have a pointer to an object, whereas if it's a primitive type like an integer, it will make a copy of it when you call it. It makes a copy of it in new memory location, but an object is always a pointer to a specific memory location. It does have some implications, but not so much for us right now. There might be a difference. Actually, a lot of the online and book discussions say that differentiating the difference between these two is really pretty irrelevant. It could have an effect in the sense that, again, if you know that if you destroy this, one of the examples they use of this is like a database table. So a database table contains, so you have a class table. It would actually, and then you have one of the things that a class contains is a row, right? So I'm going to do a collection of rows. I'll just do it like an array. And then a row is going to contain a collection of column objects. So this will be a column. And columns actually, so they contain, they have things like a name, and they also have value, whatever's in it. And these are composition. These are pretty strict composition because if you destroy a row, if you destroy the table, you destroy all the stuff that's in the table. Does that make sense, sort of? If you destroy a row, you destroy the columns in the row. If you destroy the table, you destroy all the rows and the columns. So these are wholly contained within the table. This actually would kind of relate to your data structures. That's the type of thing here. So those are the four relationships. Does that make sense? I'm going to write a little note about aggregation, and then we'll call it somewhat good. Aggregation means the class is contained in another class, but also has a separate existence. So I would say composition is actually, or aggregation is fairly common. There are a lot of classes that contain other objects. Right? When I do like a student with a grade point, I'll do the grade as an object because the grade has a couple of components, and there'll be a list of grades. So it would be kind of this. Probably, if you were to get rid of the student, the grades would be irrelevant. But I don't know. We could argue that either one of these. It's these are a subtle difference, and it doesn't matter too much in actually how you code things. So it's more of a conceptual difference between them. It could matter if you know that destroying an object destroys other objects. In Java, one of the things that's typically this kind of relationship is like an event. When you do, have you guys written any kind of forms or anything in objects? Like where you're creating, what is that object? What is it Java uses for its windowing forms? Libraries, I forget. What? Swing. Swing is one of them. There's others too, but swing is one. When you do swing, you want to do a click event or something. Typically, the click event is a class that's totally contained in another class, an internal class. That's definitely composition too, because when you destroy the external class, you destroy the other class. All right, so I think I am going to let this go. There's a couple of other things to talk about, but I'm not sure I want to talk about them today. Part of the next task is to take your initial class diagram, figure out if there's any repetition so that you maybe want to set up some inheritance, figure out what kind of relationships there are between the classes, and modify. That's the next group activity, but I will give you time, and we'll also give you a little bit more direction on Thursday. But to figure out what kinds of relations between the classes and how to best optimize your class structures. And I'll help you with that. The two things that we haven't talked about, but as I said, I think we've talked enough today, are interfaces and enumerations. You guys know what either of those are, pretty much? What about an enumeration? What's an enumeration?
Values.
Yeah, you can list values. It's basically like a lookup table in a database. And it gives you a name-value pair that you can use. One of the common uses, we're not going to do this, is to, in computers, all colors have numbers. So you can associate a name with a number, and you can use the name instead of the number, right, for a color. That's a common enumeration. In my card thing, which we'll look at, it does the suits. So, the 4 suits. Interfaces are a little bit more interesting and more complex. They are basically abstract methods. It's a list of abstract methods. When a class implements an interface, they have to give a body to those methods. I'll show you that next time too. I'll show you a little bit about enumerations and interfaces next time. And then you have all the pieces. It can take years to figure out how those pieces go together, but you have all the pieces for object-oriented programming. Questions? Did I totally confuse?
Yes,
Yes.
because the things are all line the same shape, and it's you know, a diamond with a line, it's kind of a string.
Well, so there's what is the, these are the, that is aggregation. The filled in diamond is composition.
That is a aggregation.
Yeah, and then this is inheritance. And then a straight line is just association to show that two classes just talk to each other.
Association.
Yeah. So I'm going to try to post all of this probably in the blog. I think I'll put the code in the blog too, because it's not sophisticated enough to really upload to GitHub. So I will put, maybe I'll put in a quick definition of these two, but they're in the diagrams, and I'll post this text and the pictures that I did and the code that I did and try to do some comments on it. And I think I'm going to call that it for the day, even though we tend to finish a little early in this class. I'm not sure why. Probably because I'm tired at this time of day. You can start if you want, but you've only got, you know, like 20 minutes. If you want to, I will give you next time, as I said, I'll give you more direction. So let me bring up the, and there is a video of my incoherent